So this is the acids and bases exam style question booklet. So the first question is going back to year 10. In the experiment, Joel are given a solution of sodium carbonate containing 5.23 grams of sodium carbonate powder, which is dissolved in 500 centimetres cubed of water. They then go on to give you the relative formula mass, so the MR, and then it asks you to work out the number of moles in 5.23 grams. So if you can remember, mass over MR, just put it into your calculator, give your answer correct to 2 decimal places. The answer comes out like that. So the correct answer to 2 decimal places, so 2 points after the decimal, is 0.5. It then goes on to talk about how they have set up a titration to work out and make some crystals, which we've done in class, and there's a equation as well, the symbol equation. It then goes on to give their results, and it says, state the purpose of carrying out a trial run, to estimate what you think your results would be, or to get a rough result. So it makes it easier then to carry out the rest of the titrations because you know what value you should be getting close to. State whether the sulfuric acid or sodium carbonate solution is more concentrated. Give the reason for your answer. Sodium carbonate is more concentrated because it's in a lower volume. So the lower the volume, the higher the concentration. There's more particles in it to collide, so you don't need as much. That's why the volume's lower. Use all the information to describe in detail the other 2 stages Dylan and Joel carried out to obtain pure sodium sulfate crystals. So once you've worked out what your actual volume of sulfuric acid is, you then repeat the experiment without the universal indicator. Okay, so to make pure crystals, you won't have the universal indicator. So you run your titration exactly the same, but without the universal indicator, because you know exactly what colour when it's gonna change to neutralize. Use 25 centimetres cubed of sodium carbonate and 27.65 centimetres of sulfuric acid. I've worked that out by calculating the mean of them 3. Leave to evaporate to crystallise. So exactly like how you make the insoluble salts crystals, but this is how you do it if you've carried out a titration first. Next question then. A teacher's marking a student's book who had completed a topic of work on acids and alkalis. Correct the 3 errors that were circled. So you could have done it in any order. I just went for error 1 first. Ethanoic acid, so it's not going to be an alkali, it's going to be an acid because it's got a pH below 7. Error 2, if it's water, got a green in the universal indicator, we know it's going to be pH 7. Sodium carbonate, if you were to go to your table of ions and do the crisscross method, sodium is Na+, carbonate is CO3 2-. Remember, you're only looking at the top, so cross them over. So you need 1 of the carbonate and 2 of the sodium. Moving on to the next part of the question, it's asking you to work out what the results or what compounds you need to carry out the test. So carbonate ions, if you add hydrochloric acid carbonate, you should straight away be thinking of what gas should be produced, carbon dioxide. How do you test for sulfate ions? Add barium chloride and a white precipitate would form. Describe the test that can be used to identify the gas produced when hydrochloric acid is added to a compound containing carbonate ions. Okay, so you're looking for the gas, it's going to be carbon dioxide. What's the test for carbon dioxide? Lime water turns cloudy. The next one then is a little bit of a neutralization question. They gave you the volumes that they were using. So 25 centimetres of sodium hydroxide solution was added to the bubble wrap insulated conical flask. 40 centimetres of dilute hydrochloric acid were added at 5 centimetres each time using a burette. And then the results are shown here. If the experiment was repeated with 20 centimetres cubed of acid added at once, how do you expect the maximum temperature recorded to be different? The maximum temperature recorded should be half, because in this one you're adding 40 centimetres, so if you're only adding 20 you'd expect the temperature to be half as the volume is half. Sketch on the graph what you'd expect if the experiment was repeated using hydrochloric acid half the original concentration. So you've still got the 40 centimetres volume, but you haven't got as high concentration. Remember, concentration is the number of particles, so low concentration would be 1 or 2 particles having to collide to react. High concentration will be loads of particles in the same volume, so the same area, having to collide to react. So what would happen is you'd still see the same temperature increase, but it would take longer. Okay, same volume rise. However, the higher the volume of acid required, you would have to add more acid to see the reaction, less particles, so slower rate. Write the ionic equation that summarises the reaction between any acid and alkalis. So acids contain H plus ions, alkalis contain OH minus ions. If you add them together, you get water. That is a simple neutralisation ionic equation, and that does come up quite often. Question 7 then was looking at a pH scale and working out what was the strongest acid, alkalis, neutral. So strongest acid would be the one closest to 0. So in this case, it was battery acid. The weakest alkali would then be the alkali that's just over 7, which I've actually got wrong, which would be blood. And the neutral substance would be 7, which is pure water. John was recording his observations with 3 different substances, A, B and C, looking for results. What would he get? So the first one, substance A, bubbles of gas produced, gas collected turns lime water milky, substance react to produce a pure solution. So anything that produces a blue solution is going to be something involving copper. So anything that's got blue in it is something involving copper. You see the gas collected, lime water turns milky, so that's going to be a CO2, something involving CO2. So of these ones down here, it's going to be copper carbonate. The next one then, no gas produced, substance reacts to produce a blue solution. Again, because we've seen that blue solution, it's going to be something involving copper. If we've already used the copper carbonate, then our only other one we can pick from is copper oxide. Then it says no visible change. No visible change. There would be a change if you put magnesium chloride in it, and there would be a change if you there would be nothing happening if you put sodium chloride in it. Sodium hydroxide is an alkali, so that means that you're just doing an alkali-base reaction. Again, quite a nice easy question that could come up looking at universal indicators and the colours. You need to know the colours. Use the information to help you complete the table below. Detergent gave a purple colour on the universal indicator. Give a pH value, so you could have put 13 or 14. Acid or alkali or neutral, it would have been an alkali because it's above 7. Distilled water, if it's got pH of 7, so it would have given the colour green, and you would have then said it's neutral because pH 7 equals neutral. Soap had a pH value of 8, so again, just using the table at the top, it would be blue, and it would be an alkali because it's above 7. Moving on then to the next one, different lengths of magnesium ribbon were put into separate beakers, each containing 25 centimetres cubed of dilute hydrochloric acid, and the temperature measured. The initial temperature of the acid in each beaker was 16. The results are shown in the table below. 2 of the temperatures are missing. So actually a nice and easy question because you just had to read the thermometers. You had 40, 41, 42. So the final temperature would have been 42, and then you just had to work out the difference between the initial temperature of 16 and the final temperature, which was 42. That actually looked more complicated because it looked like you had to work it out, but they actually just had to read the thermometer by there. So number 9 then was asking you to plot the results from this table, so the table on the previous page. Plot the results. So plot the results, and I drew a line of best fit, leaving 2 that were slightly anomalous. You couldn't have done a curve because of the way that they had ended up. A curve wouldn't have fit as many in. Use your graph to find the temperature rise if 5 centimetres of magnesium was added to 25 centimetres dilute hydrochloric acid. So you just had to draw a line up and a line across and extrapolate your data. Temperature rise would have been 10. Put a tick next to the statement which describes the temperature rise you would expect if hydrochloric acid was replaced with vinegar. So vinegar is ethanoic acid. It's an acid that is a lot weaker, but it's still an acid. So temperature rise will be lower with vinegar than hydrochloric acid because it's a weaker acid. Reason for your choice, vinegar is a weaker acid. You just need to know that hydrochloric acid and sulfuric acid are the strongest acids. Another titration. The first question on this is to say, why would you use an indicator? Well, if you don't use an indicator, you won't have any idea of what is going on. You won't be able to see the neutralization when the acid and the alkali form water. So we use an indicator to see neutralization. State whether the acid or alkali is more concentrated. Give a reason for your answer. Whichever one has the lowest volume, and in this case it's sodium hydroxide compared to hydrochloric acid. Whichever one has the lowest volume is more concentrated. Calculate the mean volume of hydrochloric acid needed to neutralize the 25 centimeters. You do not, oh no you do, because there's 4 runs. I thought that one was a trial run, that's why. So you do include all 4 because it doesn't say it's a trial run. So you add them all up and divide by 4. If that one had said it was a trial run, then you wouldn't have put that one in. Using the information provided and your mean volume, describe how pure sample of sodium crystals can be made. So you're essentially, like I've said before, carrying out the titration again now that you've worked out the mean volume. So use 29.5 centimetres of hydrochloric acid, 25 centimetres cubed of sodium hydroxide. That stays constant because it's up there. You repeat it then without the indicator because you know exactly now how much hydrochloric acid you have to use. You just titrate the exact amount in. Then you would filter out the solution, exactly like how you make crystals, and place on a Bunsen burner for crystals to form, or you could just leave it in an evaporating basin over a period of a couple of days. The most important thing here is to repeat without an indicator, and to get the extra marks out of 4, you need to include that you would use that mean volume of the acid. And then I do a couple of questions. One method of preparing salts. So this is now making the salts without titrating them. State what the pupil can see when all the acid is used up. So when all the acid is used up, you should be able to see excess copper oxides. That's when we know the reaction has finished because they can't react anymore. State the process used in stage 2, so that's filtration. Name the substance removed during stage 3, H2O, so we wait for it to evaporate, the H2O evaporates off. Give the name of the base used in this experiment, copper oxide, because that's the acid, that has to be the base. And give the name of the salt formed. So you obviously, sulfuric acid is end name, its surname is going to be sulfate, and its first name is going to be copper. The next question then is just carrying out the same experiment of making copper crystals. So describe the laboratory method of making crystals, but in a long answer form. So each stage needs to be weighed out. So it says you've got to make potassium chloride. So the first thing you've got to do is pick your acid, which is going to be hydrochloric acid to give you the chloride. I then pick potassium oxide. You could have picked potassium carbonate, potassium hydroxide. That's up to you. So the first thing then is dissolve. So you add the hydrochloric acid to the potassium oxide, stir until you see excess potassium oxide. So exactly like the previous question, this means all the acid has been used up. So that's the first stage. Second stage then, filter. Using a funnel and filter paper, filter the solution. The excess solid should be left behind and you have a clear solution of potassium chloride. Finally, evaporate. Place solution in evaporator basin and leave for a day for the water to evaporate. Crystals should form. You can place it on a Bunsen burner, but you get better crystals if you leave it for a day or 2 for the water to evaporate. Then it says to include a chemical equation. So hydrochloric acid, your acid, plus your alkali potassium oxide makes potassium chloride plus water. If you were then looking for that 6th and final mark, you would have had to have done a balanced symbol equation. You need to know that hydrochloric acid HCl, you could have worked that out then from using your ions table, and then you could have worked them out as well again using your ions tables. The only one you would have needed to know in that situation was hydrochloric acid. Finally, quite similar to the other questions, so as you can see, there's only about 3 types of questions they ask you: a titration question, making a crystals question, or a question on the pH scale. So, state what would be seen when excess zinc carbonate is added as solid at the bottom. So when you've got sulfuric acid, you add it in. When it's in excess, you'll see a solid at the bottom. State why excess zinc carbonate is acid to ensure, because you can't see it, you don't know how much you're going to need, so ensure all the acid's used up. Draw the apparatus you would use to carry out stage 2. Label the excess zinc carbonate on your diagram. So you can see here, that's what you'd use: filter paper, filter funnel. You'll have pure zinc sulfate down here, and the excess zinc carbonate would stay in the filter paper. Put a tick next to the box that shows the estimated time it would take for all the water to evaporate from 25 centimetres of zinc sulfate solution. It's not going to take 1 hour. It's not going to take one school term. So by process of elimination, it's going to be 1 week. I'd say a couple of days, but 1 week is what they put there.